course, will be after the lunch time. We'll talk over there about the material reinforced with particles. So now the lecture will focus on technology for plastic materials. I will make a general idea, as always, concerning here about the direct pressing, transfer pressing, injection molding, processing of plastic sheets, and coating technology with plastic materials. So the most common method of processing plastic materials are pressing and injection molding. Yeah? The pressing we can split into direct pressing and transfer pressing. And you can see, on the figure 1, steps of direct pressing. And in this technology, it's quite, let's say, easy to use, and it's simplest, let's say, technology. Because we have to put the raw material inside of the mold, we have to lift the piston, we have to push the piston over here, and afterwards the third step of the technology, lifting the piston, and of course the last one based on removal the part. But because the technology is simplest one, we have also the disadvantage, because the material, about the state material, the material is not in the molded step, okay? So we heated also the mold, but the material, let's say, doesn't reach the melted stage. And that's why, this is the reason why we cannot obtain the complex part of the complex shape of the parts, take into account different, let's say, flow possibility of the material, to fill all the part of the cavities. Another disadvantage, you can see here, lower quality of the part, of course, with complication configuration. So the disadvantage says that we can go further, to obtain the complex part, but without quality of the surface of the part that we obtain. This is the reason why the transfer pressing, I mean the next one, overcomes the disadvantage of the direct pressing. So you can see here all the steps. What is new in this technology? So the material on the first step, you can see we have to put the material inside of the chamber number 3, okay? I mean pressing chamber, let's call, but in the same time is the heated, with different temperature. And the material reach here the melted state of the material. So 2 days ago, I think someone mentioned, which is the difference between transfer technology and injection molding. It's about the productivity here. So the material reached the melted state, and afterwards you can see on the second step, push the piston and so on. We have also a runner, as in case of injection molding technology. Afterwards you have to make, let's say, the disassembly, of the equipment, and afterwards to removal, to extract the part that we got. So the transfer technology from this point of view, let's say, it's good one, but without high productivity compared with the injection molding technology. The main parameters of pressing process are pressing temperature, it's important one, the specific pressing pressure, and pressure holding time. Why do you need the pressure holding time? Why? You will see afterwards. For the
setting of the setting setting of the plastic.
Yes, yes, setting and for the uniformity, yeah, of the structure inside. I mean compact, yeah, structure of the material. You see on the injection molding that we need, let's say, period of time, and afterwards the cooling time will start it, okay? And shrinkage of the material will appears, and the material will send, of course, a little bit more material inside of the cavities. So let's go further to the injection molding technology. Yeah, of course, it's one of the most used technology for plastic material, high productivity. Yeah, there are different types of injection molding machine. We will make a short presentation afterwards. And as my opinion, yeah, the most, let's say, important phenomena consist in pressure variation inside of the mold. So we'll start from zero, yeah, for the pressure, yeah. Afterwards, the pressure reach the maximum value, and now we need a team for the pressure holding time, yeah. We need a period, yeah, for pressure holding time for the compact part, for the structure, and afterwards, here on this point, we started the cooling time, yeah, yeah. On another point, yeah, because of the contraction of the material, yeah, and reduce the volume inside the injection molding machine, we send, let's say, a little bit more material in order to fill all the cavities of the mold. And of course, afterwards, the cooling time is carry on, yeah, but on the end, the pressure will not be zero. Will not be zero, yeah. Even on the period of time that the mold is open. So this pressure on the end of the project, I mean remanent pressure, it's quite important, yeah, because if the value of this pressure is high one, we can have, let's say, a big issue concerning the extracting, concerning the rejecting of the part from the mold, and we can also destroy the surfaces, yeah, from this point of view. You can see all the steps of injection molding technologies, yeah. In my lab, you saw yesterday a short movie. Actually, in my lab, we didn't use this step, yeah, but the technical literature show us, yeah, all the, let's say, 5 steps that you can see over here, because we decrease the productivity, as my opinion. It's not necessary, yeah, to come back the cylinder and afterwards starting with the new cycle, injection cycle, to come again in contact with the mold. It's not necessary, as my opinion. We are working without the first step. Also, you can see again, yeah, two, let's say, two cavities for the mold, yeah, with the main parts. I mean nozzle, charge, sprue, yeah, runners, and the small gates. Yeah, I just remember yesterday about how to design the mold, and I show over there that the gates are around 2 millimeters, 3 millimeters for the diameter. Yeah, and of course we need the ejector pins. The ejector pins, of course, it's up to the part that we got. In case of cylindrical part, we have not the ejector pins. We have the ejector plate, okay? Because it's not possible to use the ejector pins. It's up to the part. You can see also types, let's say, main types of the injection molding machine. I think the information is good, and you can see here the general classification according to plasticized way, according to the clamping type, and according to the orientation of the machine. So, from this point of view, we have plugger type injection molding machine and screw type injection machine. Okay? According to the clamping type, hydraulic injection machine, I put a little bit information, is used common injection machine with common cost. Electric injection machine will be suited to high cleanliness products such as medical, food equipment, as well as electricity expensive area and so on. And hybrid injection machine. Let's say hybrid injection machine are the last generation, the injection molding machine, and are used in case of high accuracy, and the cost of the hybrid injection machine is less than electric one, also reduce the pollution and of course noise problem. Because inside of the lab, when you use the injection molding machine, of course there are a little bit pollution, yeah, from this point of view. According to the orientation, we have vertical type injection molding machine, horizontal type injection molding machine, and angle type injection molding machine. Actually, we are working on horizontal type injection machine, yeah, and as I mentioned before, nowadays are new model injection machine, let's say big component injection machine. I mean with 2 cylinders, yeah, one horizontal one and one vertical. It's quite good because we can get different parts with different materials. You can see here the machine with the screw type, okay, and the machine with the plunger type. Let's see a little bit advantage and disadvantage concerning the horizontal injection molding machine, hydraulic, electric, and hybrid types. And in case of hydraulic injection machine, some main advantage are such as lower initial price, cheaper parts, stronger parts, power, simple, and easy using. But in the same time, for this type of machine, there are also disadvantages. I mean, it costs higher running cost, it takes time to start, high power consumption, maintenance takes time, difficult to precisely control, compared with servo motors, not good at fine control, and risk of oil spill. Another one, I mean electric injection molding machine, energy efficiency from this point of view, less downtime, faster process, clean operation, high precision and high reproducibility, quite and eco-friendly. Very important, let's say, advantage from this point of view because it's electrical one. But there are also some disadvantages. The molding machine itself is more expensive than hydraulic one, difficult to increase the injection speed, cannot run behind the limit of the servo motor, need runtime maintenance, wear and tear parts that require regular replacement. And of course, we can mention another advantage, disadvantage for each type of injection molding machine. I put over there, as my opinion, I mean the most important one. Hybrid machine, I mean, in case of advantage of hybrid injection molding machine, diversity, best for both, and I put a little bit comment what means best for both, less downtime, price point, and of course energy efficiency, low temperature, closed loop process, exceptional clamping force, high precision production, accommodation, thick and thin wall parts, design variety. But in the same time, you can find some disadvantage. I mean, risk of product mismatching, requires hydraulic and electric maintenance procedures, and so on. And vertical injection molding machine. Vertical injection molding machine, you know, the floor area is small, of course, because it's working on vertical position. And only about, let's say, half of the horizontal machine, yeah, for the floor area. A simple robot with precise control can retrieve each plastic part cavity. The vertical injection molding machine is equipped with the transmission device which can realize automatic production and molding. Another, let's say, technology in order to obtain the plastic material, you can see over there the mold mechanical forming. This is quite simple, also process. I mean, the process takes place in the hydraulic or pneumatic press, and we can use the pressure between 0.035 up to 1.05 megapascal. In this case, must be executed both shaft and piston from steel or aluminum with steel reinforcement and provided with iron removal channels. You can see here, yeah, the iron removal channels, I mean the 4 and the 5. The, let's say, technology is quite simple, but the plastic material sheets, you can see, it's compulsory to be fixed, yeah, on both ends. Otherwise, it's not possible, yeah, to obtain the final product. Of course, we have here, yeah, the electrical resistance in order, yeah, to increase a little bit the temperature, yeah, between sheets. Another technology is the pneumatic forming. Pneumatic forming, this is the same. Also, you can see here the steps of the pneumatic forming. So, also it's important to fix the sheets on the both ends. In this case, we use the cover, this number 2, yeah. And of course, we need also the channels. I need air removal channels. Otherwise, we can obtain what? Some bubbles, yeah, between, let's say sheets. We can use also, I think, to put yesterday some movies, yeah, how it works, but you can find on Google. Yeah, it's not necessary, as my opinion. Yeah, you can find on Google. Today we can find on Google everything. Yeah, no problem. Yeah, the students also can find on Google, yeah, all the theory that professors, yeah, more or less present during the lecture. That's why my opinion is that our lecture, must be more practical one. Okay? Yeah, in order to attract more and more the students. So, of course, you can see here in case of pneumatic former, the heater system, okay, and so on. The vacuum method is the opposite of pneumatic forming, yeah. I made a mistake. This is the vacuum, of course. Yeah, you can see. Yeah. So the vacuum forming is the opposite of pneumatic forming. We need a vacuum pump. Yeah. Yesterday on the lab, you see, yeah, the application of Professor Harshit. We have to put also to fix the plastic sheets. Heater off, and afterwards we use the cold air. And of course, finally, we can, let's say, reject, we can extract the part that we obtain. From the research point of view, as my opinion, here, it's a huge also research area. Why? First of all, because we can use different plastic material sheets. Yeah, we can combine, let's say, each other. Yeah, take into account the initial property that is better to know. Another reason that I mentioned, yeah, why it's huge research area.
This seems to be one of the key methods to form composites. It's not easy to form composites otherwise. So this seems to be one very good method.
Yeah. It's an easy, simplest also way, yeah, to form the composite. Okay, and you can see how it's working. Of course, yeah, heat it first. And afterwards, the pump, vacuum pump is working, yeah, and the material are obliged, yeah, to have the shape, yeah, of the mold. Okay, coating technology with plastic materials. This is quite important technology. Why do you think it's important technology? In this case, a method of coating part that you can see over here, we use the polyamide powders, and the process is called rilsanization process, which consists in immersing the part heated before, range of the temperature, 553 up to 673 Kelvin, in a mass of polyamide powder we call rilsan. In the suspension, the powder is placed in a vat equipped with a stilling chamber, and between the vat and the stilling chamber there is a microporous bronze plate with the thickness between 2 and 5 millimeters. And all the sketch you can see over here with the main parts, yeah? I mean the result polyamine inside, over pressure number 2, okay, here, stilling room number 3, garnish number 4, and of course the microporous number 5, and number 5 here, bronze plate. You can see here the image. Actually, this image is the detail from this part, okay, to see how is placed all the elements, included the garnish, I mean rubber garnish, yeah, for this part. This technology has also, let's say, the automatic method. Yeah, we have in our city the companies that working, yeah, on this technology, and in case of continuous, let's say, flow rilsanization process, you can use something like that. I mean, the technological process included the following steps. You can see here the main area, yeah, that the part must be followed. In the first one, the surface are prepared, because in the first step, the roughness of the surface must be higher. Okay, so we have to prepare first the roughness, the surface of the part. The second one, we put the part inside of the oven with the controlled temperature. So it's up to the temperature that we use for polyamide, and so on and so on. So the main idea is to go to the next step to heat, yeah, inside of the oven all the parts. The third one, the powder is fluidized and polyamine is deposited, and you can see over there on the hot part on the tank number 4. We can find here inside the polyamide, and the last part you can see it's, let's say, on the air atmosphere, yeah, the part is cooling, yeah, cooling process. We can use also the water, yeah, as cooling system. But before this one, the part must be, let's say, stay a little time, yeah, in the stilling chamber number 5, and afterwards, yeah, go through to the atmosphere or maybe water. Okay, 2 days ago, I present, let's say, some steps how to design the injection molding. So we already present the calculation weight part, choice of the injection molding machine, total type cycle, number of the mold cavities, cavity dimension according, and so on. Now let's see the other steps, yeah, I mean a little bit discussion, yeah, for the next one. I don't know if you are following on your faculty how to design the injection molding. Did you have the project or something like that?
Yeah, the tools, the mold, right?
Yeah, you have the mold, for sure.
Yeah.
But did you have the project with the students? I mean, how to design the injection mold? Have you? During the classes with the students?
I don't think so.
No? You don't have?
But in my lab, I have the extruder, but it has to be serviced.
This is different. Yeah? If the students learn the steps how to design the mold. Something that I present. No. I think it's
Casting method in forging rust, the casting we.
this is the technology. This is technology. I said about the steps how to design the mold for the injection molding technology. Because we can obtain the part, but we need the mold. And it's important to know how to design it and to design it on the end. Okay?
There is an introduction, but there is not elaborate.
Now you can say that we have 3D printings.
Metal mold.
Better to spend to make all the calculus and so on. Yeah, I saw in Germany 3D printings with powder, metal powder. Yeah, of course, specific binder. Yeah, I saw over there. Yeah, how the mold were created using the 3D printing. Yeah, it's true, but it's expensive one.
Conformal
Yeah.
cooling.
But
Take
this
into
is a
account the
larger
equipment.
components.
Yeah, yeah,
Printing is limitation in 3D printing.
yeah.
Whereas
More.
in this case, we can able to print the large components.
Yeah, but it's also classical one. It's important because the engineer, as my opinion, must know first how to design step by step, and afterwards to go over there to follow the steps to make let's say the 3D model and so on, and to obtain the injection mold. So this was the part that we choose. Calculation of the weight part, choice of the injection molding machine, the characteristics, how to make the total time of the injection cycle. Actually, I added, yesterday, because what is it? Is the pressure variation, that I done 2 slides ago. Yeah, you can see here which is the cycle time. Okay, starting with the fast closing of the mold, and afterwards all means, including also the cooling. You can see maximum pressure value, and afterwards cooling. Of course, a little bit different diagram, but you can see also what means the cycle time, starting with the fast closing, mold closing time, cooling time, and of course part, let's say, rejection is also the part of the injection cycle. Number of the mold cavities, the dimension according to the shrinkage of the plastic material, important, very, very important step, because we are talking here about the tolerance, accuracy. And some resistance calculation. Actually, the students, they don't want to make the calculus concerning the resistance, but are very, very important from this point of view. So it's important to follow the step concerning the internal pressure and injection molding clamping force. It's quite important, clamping force. Yeah? Why do you think it's important, clamping force? Because during the injection time, please.
To pack the material inside.
Yeah, of course, Otherwise, the pressure, during the injection molding, the pressure is between 50 up to 250 megapascal. Okay? So during the injection, the pressure, the pressure of the material with the high temperature can lead to open a little bit the mold. And in this case, of course, we can lose the material, and of course the final dimension of the part will not be okay from this point of view. That's why the clamping force must be bigger than the force developed by the pressure of melted material. All the injection molding machine have a little bit, let's say, a correction concerning the clamping force. I mean automatic or manual correction, and we can push over there on button, and find, let's say, correction of the clamping force. This is quite important. You can see here the relation, how to make the calculus, the internal pressure. Take into account, of course, the injection pressure of the injection molding machine. You remember from the initial table. And in order to calculate the clamping force of the mold, is required to determine the effective area of the piece projection, part projection, and the runner of the split mold, I mean on the separate plan. This is quite easy. Yeah, the students, you know, found sometimes difficult, but it's only the geometrical calculus. It's not difficult because you can see here, yeah, this is what? This is the runner. Yeah, did you remember? This is the runner. And here we have the cavities. Yeah, I mean 6 cavities, but we can obtain, yeah, for others, let's say, dimension of the part, we can use 8 cavities. Yeah, so this is the runner. We split the runner, let's say, in simple geometrical parts, yeah, cycle, square, and so on. And afterwards, we only have to make the calculus. Yeah, we have to establish exactly all the dimension and to make the calculus for the whole area. Okay, this is important. It's not difficult. And you can see here the sketch, yeah, concerning the clamping force also. And afterwards, the inner maximum injection force is determined by the relation. Yeah, I mean, we can choose the coefficient between 0.4, 0.6, multiply by external pressure, and multiply the final area that we already made the calculus. Okay? Always when we have, let's say, to choose the coefficient, we choose always the middle. Yeah? This is the best solution. Yeah? So we'll choose here, let's say, 0.5. The clamping force is determined by the relation afterwards, you can see. I mean, another coefficient multiplied by maximum force that we already calculated. And the clamping force, finally, we have to see the value is less than the clamping force of the injection molding machine that we choose. I mean, this is the best result or not? It's the best, yes, because the calculated clamping force must be, of course, lower, yeah, than clamping force of the machine. Yeah. Also, in case of volume of the part, the volume, of course, if the volume will be, let's say, bigger and the clamping force bigger, we have to go further. We have to choose another injection molding machine.
Yes.
Checking the closure surface of the mold, you can see also the top view of the plate with the mold cavities. Now, let's say we are in the position to make all the to establish all the dimension of the active plate. Yeah, we can put here everything, all the dimension, and of course to check the dimension, because afterwards, you know, all the dimension of the rest of the plates of the mold, yeah, are bigger compared with active one. Okay. We have to calculate also the closing surface area. Some condition to have satisfied. Sizing of the forming plates. You can see the forming plates with cylinder shape for injection, let's say the bush part. Yeah, we can make a sketch something like that always to put the internal pressure of the machine, to put the maximum diameter of the part, I mean the minimum diameter of the cavity. Yeah, and afterwards the inner diameter of the forming plate was constructively determined and can be used. You can see the relation, something like that. Checking the plate's forming stiffness, the arrow F, in this case a forming plate with cylinder shape under the internal pressure, is calculated, you can see, using this relation. Because the height of the part, let's say it's small one, did you remember 36 millimeters? Yeah, so it's not a problem from the arrow point of view, but you have to check, let's say, the value. And the important conclusion here, yeah, on the piece counter will not appear the bar because the effective error calculated, it's, you can see, lower than in case of admission value. Sizing and checking the punch. This is the loading of the punch, yeah? You can see, and afterwards we will have here the part and all the sketch that we needed. And the punches of the mold have a circular section and are under the bending stress, and the type of the loading is shown on the figure below. You can see how to make the calculus in case of bending unitary stress and the bending moment, and of course also the bending modulus. Here we have two steps, I mean for sizing and for checking. Yeah? It's compulsory to use this relation in case for sizing, and afterwards, in case for checking to use this relation. Other words, yeah, you have to change if let's say the unitary stresses, it's let's say bigger than suitable one, let's say, what it will happen? We have to change the material. We have to change the material. Another one, yeah, another steel with bigger, let's say, stress, and so on. Sizing and deformation of the mold plates. I put here some information in order to make a general idea about which are the main parts, because we have two main parts of the mold. And you can see here the machine movable platen, number one, because during the open the mold, only this part will go on the left side. This one is fixed one, okay? Another one, ejector plate, number two. Yeah, we have here inside of the plate another plate with the ejector pins fixed, yeah, on the plates. Mold ejector plate, mold cowl plate, number 4, forming plates, number 5, 6, punches, forming plate, number 6, okay, fixed clamping force here, and the last part is the machine fixed platen. And of course, you can see here we have a taper, yeah, shape, because over there will come the nozzle of the cylinder, okay? You can find here that the sketch will carry on something like that, okay? Okay, the same for arrow. Choosing the cooling system. What do you think? The cooling system, it's important or not?
Yes.
It's very important, the cooling system. Nowadays, there are thermoregulator equipment, very small, a little bit bigger than a computer, yeah? And it's compulsory to check the technical literature to see over there which is the suitable temperature for the mold, yeah, take into account the plastic material used. Different, let's say, information. In case of polyamide, you have to keep the temperature of the mold around 50, or maybe the technical literature makes some recommendations such as between 50 and 70, okay, between 80 and 90. Of course, it's better to use, let's say, the lowest, yeah, value of the temperature. So, because of the punch diameter being relatively small and forming plate will be provided with cooling system. Yeah, you can see here the cooling system. Another one, cooling channel with circular section, because we need to establish everything. Yeah, and we can use also let's say another types of the cooling channels. But in this example, yeah, we have the circular type for the cooling channels. And now this is the active plate, okay? And this one represents the cooling system. I mean, how to manufacturing, okay, the cooling system inside of the active plate. It's important to have some type, let's say, of entrance and out of the system, okay, and to have the symmetrical one. Yeah, because each cavities, yeah, yes, must have the same temperature. If you can choose, let's say, something like that, I don't know to say, yeah, it's wrong one. Yeah, be careful with the cooling system. First, of course, how to draw it, and afterwards to establish all the dimension for the and shape for the cooling channels. You can see over there that I mentioned before that cooling time, we can make the calculus for the cooling time, but always using the calculus, the value of the cooling time is bigger. Yeah? That's why we have to choose, you know, take into account the technical recommendation, yeah, for the cooling time. In this case, did you remember I choose at the very beginning 20 seconds, yeah, for the cooling time. And now you can see over here is 79 seconds. So we can use it, but maybe we can increase the injection cycle time, and we can decrease the productivity, yeah, without, let's say, required issue from this point of view. So we can choose the recommendation from technical literature. In this case, the important, let's say, coefficient is the A coefficient selected, because you have to make the calculus something like that. Please.
How to maintain the uniform cooling rate everywhere? Because here, if you see, then input is only one side and output is also at one side. So maybe once the liquid, whatever the water you are using for cooling purpose, liquid medium we are using,
How
once it
can
will
they-
enter, then it will be cool. But once it will pass to the first two cavities, then again the temperature will rise, and for second cavity, the cooling rate will be slow.
No, 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 no. For sure, we have the same temperature.
But how,
We have-
how that
Yeah,
will be maintained?
because the water inside, yeah, is in a continuous flow.
But still, the first two cavity is losing some heat, and that heat is going where? It is going into the cooling medium.
No, it's not happened, as you
But
say.
can we suggest the another path, like instead of one, there may be multiple entries and multiple exits?
That is usually how it is done.
Yeah.
So there will be two concurrent cooling channels.
Yes.
So one will enter from this side, one will enter.
One end, yes, yes. Then you can maintain the uniform temperature.
No.
Otherwise,
In the practical one, it happened, as you said. The temperature is okay because you use, you know, the temperature gun. Do you know what means? Yeah. And we check the temperature,
Inlet and outlet.
as he said. We check the temperature where? Here, 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 here.
yeah.
Okay, and the temperature is the same, with the small deviation. You said,
Then
yeah.
at least the quantity
You-
of the cooling we
yeah.
are doing is more. More
You-
quantity is flowing, then it's okay. Cavity is very small size. Then maybe you can maintain the constant temperature.
Yeah, you say here, maybe the cooling agent, yeah, will have the highest temperature, yeah, compare with this one. Okay, let's say compare with this one. But in the practical, no,
Basically,
it not happen.
The diameter of the
That's why cooling pipe, yeah. Quantity of the fluid,
Quantity of the
liquid
fluid
flowing
will
is
also
more
matter.
in this case.
Yes.
Then and then you can maintain the uniform temperature.
I think those calculations are for this type of There was a slide, no, where 11 mm diameter was given of the cooling channel.
Fine.
Yeah, of course, you can ask, but really we put also this problem. Of course, we put also this problem. You can see also the values of the A coefficient. And as I mentioned before, look, it's only one example. Yeah, I mean the temperature of the injection cylinder and mold for in case of PVC. because at the very beginning we choose the PVC material for our part. Okay? So look the technical recommendation. The mold, the temperature mold must be between 20 up to the 60 Celsius. Okay? And afterwards, the technical literature make the recommendation something like that on the nozzle, yeah, which is the recommended temperature on the nozzle between 170 to 200, yeah, on the first zone, on the second zone, and so on and so on and so on. Our injection molding machine have 7 zones, yeah, to make the correction for the temperature, but actually I'm using only 3. Because take into account our experience, it's enough, yeah? Including also this zone, yeah? You can see, but it's 30, 40 millimeters. So I use only this one, and of course, yeah, the nozzle temperature, because what means the nozzle temperature? Is the melting temperature yeah, of the material, yeah? Okay, and we use between zone, even the technical literature makes some kind of recommendation. Look at nozzle, look at first zone, I mean fourth zone, yeah? How can we choose the temperature here? How? How? We can choose 200 and we can choose 190. I think this is the best solution, yeah? But always we put here, let's say, 5 Celsius, yeah, between zones. Because of the fluidity of the material, it's important to have constant one, okay? But also you can choose 10 Celsius, yeah, between zone. It's up also to the material. The thermal diffusivity coefficient, in case of PVC, of course, you can see the value from the table number 7. Our students actually here, you know, make a lot of draws from this point of view, because the next one, they must choose the drawing system, okay? They must choose the drawing system. In this example, we can see we have 2 ejector pins, okay, on both sides. Why is necessary to choose the drawing out system? Because we have to calculate for the mold release force. And you can see here the relation for the mold release force. This is quite important because the calculus take into account, you can see the shape that we use for our parts. And you can see here, in case of open cylinder, in case of closed cylinder, there are different relations for the mold release force. Look here what I said before. Different types of geometrical shapes of injected part. Open cylinder, okay? Closed one, and so on, another type, yeah? So up to the type of the part that we want to get, yeah? Of course, for the release force, we have to choose the suitable relation in order to make the calculus for release force. And of course, finally, the students must do drawing out striping plate. This is, let's say, the most difficult step, yeah, for the project, because they don't like, let's say, anymore to draw. But of course, there are several students with the best skills on computers, yeah, and they are quickly draw on computer on different software.
Very tough to draw manually.
Yeah, and they are very good, let's say, from this point of view. But another one, mechanical drawing out system, different type, let's say. The mechanical drawing out system is best used and is most effective when injected part remains in the in the mobile mode, I mean on the left mode, yeah? So on this case, please use this one. You can see how it looks. You can see also how it looks, let's say, different type of the ejector rod, of the ejector pins, yeah? Also, we have to choose it, yeah? Which type is suitable for our part. There are several types. And it's not so cheap, the pins.
Yes.
Yeah, only pin around, let's say, I think 20. Of course, you have to cut. It's up to the mold. Yeah, it's around 10, 15 euro. Yeah, it's not so cheap. Tubular drawing out in case of symmetrical parts, cylindrical or symmetrical portion with great height, with strong shrink on punch. You can choose the tubular one. Another situation, drawing out with the stripping plate, in this case, of high circular part with thin walls and easy deformer, avoid on part surfaces of trace belongs to the ejector pins. Another system is the hydraulic system. Okay, so the first one was mechanical one. Now the hydraulic system, and of course we need the hydraulic engine in this case. Also, you can use the pneumatic drawing out system, and of course we need, in this case, a pneumatic cylinder. And of course, all the students must choose in this step of the project which drawing out system they choose. And afterwards, you can see, please.
In hydraulic spring-off system, there must be they are using pins only, no?
Yes, of course.
Ejector pins.
Yeah, the drawing out system, yeah, is not in connection with the pins. Okay, the pins are separate. Yeah, the pins, let's say, take into account the type of the part. Okay, the number of the pins also it's in connection with the size of the part. Yeah, because if we have a big size of the part, we cannot use, let's say, only 2 pins.
Yes.
Yeah, because it's not possible to extract the part from the mold. Yeah, also the number of the pins must be calculated. Yeah, otherwise we can destroy it. Okay, the part surfaces. The next step is to choose the centering and driving system. I mean the mold centering in the fixed side, the fixed mold, and the mold centering on the left side of the mold. You can see also the centering solution. Also the students must draw it. Yeah, finally. It's not easy, Kappa. It's not easy. It's a lot of work. A lot of work during one semester with 2 hours project per week. Okay, it's not difficult. It's not enough time, 2 hours. Yeah, but and finally, yeah, the student must make the molding sketch. I made it for you. Let's say the 3D image. I have also the PDF file, you know, to change the position and so on. But I put this one to make a general idea about the final mold. Yeah, look, movable mold. Yeah, I mean disassembly. Yeah, type. You can see all the parts that we already designed. Okay. Fixed mold. You can see also all the part, and you can see here, yeah, the cavities. Okay. You can see here the cavities, and you can see here what are those? Yes. Okay. And the final mold sketch. This is also very, very difficult. They draw, you know, on the big dimension, okay, to make the presentation, and of course must be known very well how it's working. Yes. Yeah, because it's not difficult. In case of mold with one plane, one separation plane, yeah, it's easy. But in case of molds with two separation planes, yeah, little bit difficult. But using the nowadays software, yeah, it's easy because they made the 3D model, and afterwards, you know, yeah, I'm not involved in the computer, let's say, software and so on. Yeah, it's easy to make a section.
Sections,
Yeah,
yes.
it's easy to make a section, and they are doing very quickly. Yeah, which section do you want, professor? Yes, no problem. Yeah, if of course if they have also the 3D model. Yeah. And of course, you can see also the types of the injection molding. Yeah, as I mentioned before, this is first type. Yeah, this is the second on vertical position, and this is the B component injection molding. Yeah, we have in Timișoara there is a big company on injection molding. Yeah, actually the director over there wrote, I think, 15 years ago, the best book, as my opinion, yeah, in injection molding technology, including also the design. The book has around 400 pages, yeah, with small, let's say, font, yeah, but you can learn everything over there. Yeah, it's, let's say, a complex book and is very useful for us. Last but not least, the students must make, you know, the recommendation, must choose the materials.
Yes.
Yeah, I mean the materials for all the elements of the mold. In case of active plate of the mold, be careful that we need what?
High strength steel.
Yes, yeah. In my lab, the active plates we always make using the molybdenum chromium, okay? Otherwise, we can destroy it, yeah, on high temperature. Even, of course, we use the cooling system. We can destroy it. And I mentioned the book. You can see this is the book. Yeah, this is the main, let's say, references. Injection of plastic material. University West Publishing House, Oradea, appears in 1996. Okay, published in 1996. Yes, of course, after all, there are, let's say, several books, but as my opinion, this is the best one. Also this one friend of mine, yeah, from Galați, published also a good one version. Why? Because he put over, I'm a supervisor of this book. Why? Because he put over there, reviewer, yeah? Why? Because he put over there many examples of the different molds. This is quite useful for the students, yeah, with different parts, how to obtain, how to draw, and so on. They put, he put also many information, yeah, concerning the plastic material, yeah, starting to the melting temperature up to the physical properties, mechanical properties, optical properties, and so on and so on. So this is quite useful, yeah, to make a general idea before starting the design. Yeah, I mean to know better, yeah, to know which are exactly the properties, and the next step to follow the design of the mold. Of course, we can do, but we didn't, yeah, the economical analysis of the mold design. For sure, inside of the factory, there is, let's say, for sure, this kind of calculus, but inside of the project, we didn't, yeah? And you can make, let's say, you can use the, say, cost of the simple injection mold, cost of the complex injection mold. You have to take into account the salary and so on, materials, workers, and so on. And you know, all the costs are different from one country to the others. So that's all I wanted to tell you, to share with you, yeah, on this lecture.
Sir,
please.
According to you, which property of material need to be considered while designing mold?
Yeah, all the properties are important, as I said before, but from this point of view, I mean the mechanical properties are on the best one. Another one, thermal properties also it's important because we are talking over there about the temperature, melting temperature of the material. But not let's say in many cases, physical properties, yeah, flow properties,
Like
Kalpak very well.
viscosity or
Viscosity,
shrinkage behavior.
yeah. The material, let's say, even maybe optical, but less than the other properties, yeah, and so on, yeah. So this is the material science skills, knowledge, yeah, must be, done very well, yeah, at the very beginning, because our students follow the material science in second year, first year, yeah, first year. And from the first year up to the fourth, there are 3 years. And yes, please, Kamal.
So it's a 4-year course there itself. In Romania, it's a 4-year course. That
Yes, 4-year course for the
First
faculty.
year they study materials.
Yeah, in the first year. Yeah.
In India also, mostly third semester or second semester.
Yeah, in your institute, second semester,
Third
materials.
semester. We are teaching third semester.
Second year, right?
Third semester, second
I
year.
think the same. I
First
think
year
the
is a
same.
common.
Second.
Why we are teaching in the
First
second
year
year?
is
The
a
reason
common
being
year.
the first year is common for all engineering
For
branches.
all, yeah. And after all, they choose the specialization.
Yes.
Yeah. Well, it's not easy, but it's so nice. Yeah, when you are in the end, yeah, and you can see that everything that you've done, it's okay. Yeah, we usually put the students, yeah, but not all the students, of course, to work on the injection molding machine, because in my lab we have a rule: each, let's say, member of the research team use only one machine. Okay, my machine is injection molding machine. Yeah. Professor machine, let's say it's 3D printing. Another young colleague, CNC machine. Yeah, and so on. Because, as my opinion, this is the best way. Yeah. If you, Kalpak, wants to talk about the CNC machine, well, please, Kalpak, go to the young colleague. Yeah. And because this is the way, yeah, how to know deeply, yeah, all the information about machine technology and so on.
Bravo, Cristo.